All right. First question here just says determine area. I think the last one had area and perimeter. This one just says area. And remember, we made a big deal out of the difference between area and perimeter. If you weren't here on Friday or if you didn't get a chance to watch the video from yesterday's stuff, I feel like this is a really good summary of the difference between perimeter and area. You have to do them in different ways. And the problem is a lot of people try to do perimeter like this by cutting the shape up into two rectangles. You can't do perimeter like that. So don't try to do perimeter like that. Perimeter is done in a different way. So you could go back and watch just the first 5 minutes of the video to kind of get the talking about that. But anyway, this one's just area. So we're going to use the way that we do area. And the way we do area is I find the area of the recognizable shape. So I see a triangle and I see a circle, half circle, right? And so I have to think about how to find the area of each of those two things. And then I'll add them together. And so this is like the A1, A2 method, right? And a lot of you were using that, like writing it that way, which is great. You don't necessarily have to, but you got to try to at least have some sense to your question. So first of all, I need the formula for area of a triangle. Base times height divided by 2. You will get a formula sheet for the exam. Okay, base times height divided by 2. And what do we have to know about the base and the height of a triangle? What's so important? They have to be at a right angle to each other. So when I look at this shape, if I can get in here, I've got one side here and one length here. And they are at a right angle to each other. So that would be, one of them is my base and one of them is my height. It really doesn't matter which you call which. So one of them's 8 and one of them's 9. So we're going to do 8 times 9 and divide by 2. Do that on my calculator. 8 times 9 divided by 2. So that gives me 36. So the area of the triangle A1 is 36 centimeters squared. A2, area of a circle. Again, you need the formula for this. So you check your formula sheet. The formula for area of a circle is pi r squared. But what else do I have to think about this shape? Donovan? Yeah, it's only half a circle, so I'm going to divide it by 2. And if you can remember to do that starting from the first step, instead of what a lot of people like to do is get the answer and then add in divide by 2, and that's just that's not the way we like to write math. So it's perfect if you can remember to do it from the first step like this. And I'm going to do this because I'm working with a circle. And I see 8 is the length all the way across. So that's the diameter. And what's the relate? And so then how do I find the radius? Divide by 2, it's half the diameter. So the radius is going to be 4. And that's the one that I want. Pi is 3.14. The radius is 4 squared divided by 2. I'm going to put that all in my calculator. Whoops. At the same time, times 4 squared divided by 2. So I do it all in one step, and I got 25.12. So that's the area of half of the circle. And then the total area, I add them together. So it's 36 plus 25.12. And that gives me 61.12 centimeters squared. And again, it's perfect if you kind of have the different parts of the question separated. So I've got area of the triangle over here, area of the circle here, and then total here. You could also do that. You could give them little titles. You could be like triangle, and then calculate the area. Circle. You don't even have to call it a half circle. I know what you mean. And then total. Instead of A1, A2, but it's nice to have them separate. Any questions about that? When you look at these packages, we have one more package, the day 3 package tomorrow, and then on Wednesday we're going to do some different stuff. And I think tomorrow's package is a little bit shorter, so we might get started on some different stuff. And I also have another a big package of stuff that you can use to practice if you want some extra practice. When you look at the 3 packages, you're going to see a lot of questions coming up on all of them. That's a pretty good indication that that's something you need to know for the exam. Okay, the exam is only on, I'll do a bit more about this specifically when we're done this, but it's only on the stuff from midterm on. So everything before midterm is not really on the exam. Okay, so keep that in mind. Okay, some of the angles in a triangle is, in other words, what do the angles in a triangle add up to? What do they always add up to? 180. Good. The sum of the angles in a quadrilateral. What's a quadrilateral? Four-sided figure. So what do they add up to? 360. And remember, we can find it for any shape. We can find what the angles add up to by using the formula. But those are 2 that we know. So supplementary angles, that's angles that form a straight line. You don't need to know that word, supplementary, don't worry about it, but it's a fancy word for angles on a straight line. What do they add up to? Justin? 180. And complementary angles that form a corner, or in other words, a right angle, add up to what? No. 90, right? A right angle is 90 degrees. So that's like a corner like this. Like this question right here, these are complementary. This is a corner. We know a right angle is 90 degrees, so obviously they have to add up to 90 degrees. So very simply, how do I find x? 90 minus 55. So it's 35 degrees. And I put my answer on the line. Okay. Rates of change. Shaq is going to renting a hall. Ugh, that's really weird. Going to rent a hall for a school dance. There's a cost for the hall and a cost per person. So which one's the initial cost? Which one's the cost per person, right? That's what we're looking at here. The formula for that gives us the formula though. 10n plus 500. Is this linear or nonlinear? Give reasons. What do you think? Justin. Yeah, there's no reason why this would curve. It's going to be a straight line. It's linear. When it say give a reason, it just means like whatever you think, but it has a fixed rate, right? It's going up by 10 every time. So it's not going to curve. There's no exponents. Those are the kinds of things that you could say, or it looks familiar. That is the equation that we've worked so hard on all year in grade 9. So we know that this is going to be a linear relation. And how do I know which one of those numbers is the rate per person and which one is the cost of the hall that you just pay one time? How do I know? Look at that equation. It's got 2 numbers in it. Which one of them is the cost per person? How do you know? What's that? Where does it tell you? I don't think the question doesn't say $10 is the. Yeah, because of the n. Raquel, is that what you were thinking? Because it's beside the n. That's exactly right. So that's good. That's what, and that you probably didn't understand what I was asking, but that's exactly what you're looking for. Very good. The variable tells me which one is the rate, and then the other one that's just added is added once, and that's it, right? Okay, good. So that means the cost for 0 students, we've talked about this, that doesn't make any sense. Why would you rent the hall if nobody was going? But in this relationship, that would be the cost for 0 students. It's $10 per person. So for 10 students, the cost will be $10 times 10 students plus the 500, right? We can use the equation to figure that out. So $10 per person plus the initial cost. So it's going to work out to 600, but hopefully a lot of people would probably think you're starting at 500, and if you're adding 10 students at $10 per person, you're adding 100, so I should be adding 100. And if this goes up 10 students again, this is going to add 100 again. But however you get these, you can do it different ways. So adding another 10 adds another 100, add another 10 adds another 100, add another 10 adds another 100. Add a proper scale to the graph. So what do we want to count by? I think I'm going to count by tens across the bottom. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If you can, it's nice to go past your table so that I can see more values when I graph it. If you knew there was going to be about 300 students going to the dance, you'd probably want your graph to go up to 300 students, so then we would have to maybe adjust our scale. But for this question, it doesn't matter. And I'll probably want to count by 100. So 1, 2, 3, 4, 500. 6, 7, 8, 9, 1,000. Okay, so I'm gonna graph this. It doesn't actually say to graph it, but I think we're supposed to. So we added our scale. 0 starts at 500, and at 50 we're at 1,000. And then I'll draw a line. Okay. State the rate with units. So we already talked about that, and our rate is 10. What would the units be? Dollars per person. The rate should always have a something per something in the units. State the initial value with units. So that's going to be the $500. What type of variation is this? Who wants to answer that? Do you remember the two types? Who remembers what both types are called? Very nice. Direct and partial. Which one is this? Walker? Partial. Why? Yeah, because direct always starts at 0, and this one doesn't, so it's partial. Very good. Any questions about that one? Okay, another linear relation question. The cost for a ski club membership, that should be one word, is shown in the graph below. So again, I'm going to just observe a few things about this graph. It's going up. So it's got a rate. That's getting, the more times you ski, the more you pay. That makes sense. But it doesn't start at 0. It's partial. So it's got some kind of fixed membership cost as well. And that makes sense. A lot of ski clubs would have that. Some ski clubs, you buy a membership and then you ski for free. Some ski clubs, you buy a membership and then you pay per use, but you pay less maybe, right? So they have different options. So every place is going to be a little bit different. So this looks like, if I look at the scale is going up. 2 squares, 1, 2 takes me to 100. So 1 square would be 50, half of that, right? So 50 and then 50 gets me to 100. So it looks like it's counting by 50s, which means it starts at 50, and 10 times skiing goes up to 100. So that's an increase of 50. So I probably have to find this stuff anyway, but I'm just looking at some of the scale, where it starts, and thinking about this equation. Let's see, what is the initial cost for the membership? So there you go. Already figured that out. It's $50. What is the rate, and what does it mean? So again, I can't zoom in any further, but this went from there to there, which was adding $50, because I went from 50 up to 100, right? I went from 50 to 100, so that was an increase of 50. And I went from here to here, was adding 10, because it started at 0 and it ended at 10. So that means I did an increase of $50 for 10 times skiing. So I divide to see how much it was per one, right? If it was $50 for 10, How much is it for 150 divided by 10? And that gives you 5. So the rate is $5. And that's $5 per ticket skiing. Or something like that, right? Per time skiing or per outing or per day. I don't know. Whatever you want to say would be fine. Is that okay? Write the equation for this relationship. Whoops, looks like there's something wrong with formatting here because we don't really have space, so I'll just do it right here. So the cost equals, and this is, again, when you're writing your exam, you can go and look and, oh, this is what an equation is supposed to look like right here. C equals something n plus something. You can change the C and the n, but I'm going to use C and n because it's got a C here in the graph and an n here. So I'm going to use those equations. But C equals something n plus something. And what do I put? I put the initial cost here, and I put the cost per with the variable. That's what a linear equation always looks like. So it's like fill in the blanks with the rate and the initial cost. Any questions about that one? And the last question, I think, in this package is find the shaded area. So we started out with a question where I had to find the area of two different shapes and add them together. This one's different because I find the area of two shapes and I subtract them, right? Because I want this whole area, but I want this part cut out of it. So how do I do that? Well, if I find the area of the rectangle and subtract this circle, then I'll be left with just what's left, which is the shaded area, which is what I want. Okay? So we'll call this area 1, and that's the rectangle. So that's just length times width, 10 times 20, which is 200 meters squared. And we'll call this area 2. And no tricks this time. It gives me the radius is 2. The diameter would be 4. I don't need that. So area 2 is pi r squared for a circle times 2 squared. So that's 3.14 times 2 squared, which is 12.56. And then the total is area 1, minus area 2. And make sure you do the bigger one minus the smaller one. 200 minus 12.56, which is 187.44 meters squared. Any questions about that?